When you hear the term black hole, it probably brings to mind images of a giant cosmic vacuum, endlessly sucking in planets, stars, and even light itself. Black holes are often portrayed as terrifying monsters of the universe, silently roaming space and devouring everything in their path. But while they are some of the most extreme objects we know, the reality of black holes is far more fascinating and far less dramatic than science fiction suggests. So today, let's slow things down and ask a simple but powerful question. What exactly is a black hole? Let's dive in, right here. To understand black holes, we first need to talk about gravity. Gravity is the force that pulls objects toward each other. Earth's gravity keeps us on the ground. The moon's gravity affects the tides, and the sun's gravity holds the entire solar system together. The more massive an object is, the stronger its gravity becomes. Most of the time, this balance works perfectly. Stars shine, planets orbit, and galaxies stay intact. But under certain extreme conditions, gravity can completely overwhelm everything else, and that's where black holes are born. A black hole forms when a massive star reaches the end of its life. Stars spend most of their existence burning nuclear fuel in their cores, producing energy that pushes outward and balances the inward pull of gravity. When that fuel runs out, the balance collapses. For smaller stars, this collapse might result in a white dwarf or a neutron star. But for stars much more massive than our Sun, gravity wins in a dramatic way. The core collapses in on itself, compressing an enormous amount of mass into an incredibly tiny space. The result is a black hole. What makes a black hole truly unique is not just its mass, but how tightly that mass is packed. Imagine squeezing the mass of the Earth into the size of a marble, or the mass of the Sun into something just a few kilometers wide. When matter is compressed to this extreme, gravity becomes so strong that nothing can escape it, not even light. This is why black holes appear black. They don't emit light the way stars do, and once light crosses a certain boundary, it can never come back. That boundary is called the event horizon. The event horizon is often described as the point of no return. Once something crosses it, escape is impossible. Not because the black hole suddenly pulls harder, but because space itself is so warped that all possible paths lead inward. From the outside, the event horizon looks like a dark, invisible surface surrounding the black hole. From the inside, however, the laws of physics as we know them completely break down. At the very center of a black hole lies what we call a singularity. This is where all the mass is thought to be concentrated into a point of infinite density. The word infinite is important here because it signals a limit to our understanding. Our current theories of physics, including general relativity, cannot fully describe what happens at a singularity. It's a place where space and time are stretched to their absolute extremes, and where our equations stop making sense. One common misconception is that black holes constantly roam the universe, pulling everything toward them like cosmic whirlpools. In reality, black holes behave much like any other object with mass. If our Sun were suddenly replaced by a black hole of the same mass, Earth would continue orbiting almost exactly as it does now, except of course without sunlight. Black holes only become dangerous when you get extremely close to them, well within their gravitational reach. There are different types of black holes, and they vary greatly in size. Stellar black holes, formed from collapsing stars, are typically several times more massive than the Sun. Supermassive black holes, on the other hand, are millions or even billions of times more massive. These giants sit at the centers of galaxies, including our own Milky Way. Scientists believe they play a major role in shaping galaxies, influencing how stars form and how galaxies evolve over billions of years. You might be wondering how we could study something that doesn't emit light. After all, if black holes are invisible, how do we even know they exist? The answer lies in their effects on their surroundings. Black holes often have disks of gas and dust swirling around them, called accretion disks. As material in these disks heats up, it emits intense radiation, especially in X-rays. By observing this radiation and the motion of nearby stars, scientists can infer the presence of a black hole. Black holes also have a strange relationship with time. According to Einstein's theory of relativity, time slows down near massive objects. Near a black hole, this effect becomes extreme. To an outside observer, an object falling toward the event horizon would appear to slow down and never quite cross it. For the falling object, however, time continues normally, at least until it reaches regions where our understanding of physics fails. Despite how extreme they are, black holes are not just cosmic oddities. They are laboratories for testing the fundamental laws of the universe. By studying them, scientists hope to better understand gravity, space-time, and the origins of the cosmos itself. Black holes push physics to its limits, forcing us to question what we know and explore what we don't. So, what exactly is a black hole? It's not a hole in the traditional sense, and it's not a mindless destroyer of worlds. A black hole is a region of space where gravity has become so intense that it reshapes reality itself. It's a reminder that the universe is far stranger, deeper, and more beautiful than our everyday experience suggests. And the more we learn about black holes, the closer we come to understanding the universe and our place within it.